So here's a core rule in Java. A class can't have two parents. It's strict. But what happens when your code really needs to wear multiple hats? Well, that's where interfaces come in. They are Java's absolutely brilliant way of giving your code incredible flexibility. And today, we're going to break down exactly how they pull it off. I mean, really think about it. Maybe you've got a report class. It needs to be printable, right? But you also need it to be loggable. Or maybe you have a button that has to be clickable, but it also needs to be resizable. How in the world can one single class juggle all those different roles when it can only inherit from one parent? Well, that is the exact puzzle that interfaces were invented to solve. And this slide just lays it all out perfectly. On the left, you've got class inheritance. It's kind of like a family tree. You get everything, the good and the bad, from one parent. But look over on the right. Interfaces are more like collecting skill certifications. A class can get certified as drawable, serializable, you name it. It's basically promising that it knows how to do these specific jobs without being locked into a single family line. So if interfaces are like certifications, what exactly are they certifying? Well, that brings us to the big idea. An interface is a contract for your code. It's all about separating the what from the how. The contract lays out what a class promises it can do, but it leaves the how, the actual implementation, completely up to the class that signs on the dotted line. But why go to all this trouble? Well, it's about getting all the benefits of having multiple identities without the massive headaches. A class can be a printable and a loggable. It gets to be both types without inheriting messy, conflicting code from two different parents. This completely sidesteps the infamous diamond problem, where a class inherits two versions of the same method and just freezes, not knowing which one to use. The end result? A super flexible plug-and-play system where any component that follows the rules can just be slotted right in. Okay, theory's great, but how do we actually write one of these contracts in code? It all starts with a simple keyword, interface. This is how we define the blueprint, the official list of requirements for any class that wants to take on a specific role. And you know what? The blueprint itself can be incredibly simple. Just look at this callback interface. It's only making two declarations. First, a method signature for callback. Notice there's no code inside. No curly braces, nothing. It's purely a promise about what the method will look like. And second, it defines a constant, max retries. That's it. Now, what's really cool is that Java does some of the work for you. Any method you declare in an interface, Java just assumes it's public and abstract. It's a public promise that's waiting to be fulfilled. And any variable, it's automatically public, static, and final. That means it's a constant that's shared across every single implementation, not some variable that's unique to each object. A contract is just a piece of paper until someone actually signs it. In Java, a class signs an interface's contract by using the implements keyword. This is the moment of truth, where a class officially promises to deliver on every single one of the interface's requirements. And here we go. Our client class is stepping up, declaring that it implements callback. This is its binding promise to the compiler. It's saying, yep, I see the contract and I will provide the actual real-world code for that callback method. And boom, right there in the curly braces, you can see it making good on that promise with a real implementation. Now, fulfilling the contract comes with some strict rules. You can't just wing it. First, you have to implement every single abstract method. No skipping. Second, your implementation has to be public. And third, the method signature, the name, the parameters has to be an identical match. But here's where the real power kicks in. A class isn't limited to just one contract. It can implement as many interfaces as it needs. You just list them out, separated by commas. Okay, so all these rules and contracts, they're all building up to one of the most powerful ideas in all of programming, polymorphism. It sounds super fancy, but it really just means many forms. It's the ability to write a single piece of code that can work with objects of many different types, all because they share the same contract, the same interface. Let's see this in action, step by step. First, and this is critical, we declare our variable C using the interface type, callback, not a specific class. Now we can assign a client object to it. When we call c.callback and Java looks at the object at runtime and runs the client's code. But here's the magic. We can then assign a totally different object, let's say another client, to that exact same variable. The next time we call that method, Java dynamically finds and runs another client's version instead. And there's the proof right there. The exact same line of code, c.callback42, produced two completely different results. Why? Because the actual object hiding behind that interface variable changed. This, right here, is the secret to building flexible, adaptable software. But this incredible flexibility comes with a really important safety net. When you're holding an object through its interface, like our C variable, you can only see and use the methods that were defined in that interface's contract. The client object might have a dozen other public methods, but from the perspective of the callback interface, they might as well be invisible. The contract is your entire world. For a long, long time, interfaces were purely abstract blueprints. They were all promise, no action. But then, starting with Java 8, they got a massive upgrade: default methods. This allows an interface to provide a ready-to-use working implementation for a method right there inside the contract itself. This named interface is a perfect example. It still has one abstract method, name, that any class has to implement. But check out that display name method. It's marked as default, and it comes with a complete implementation. This is a game changer. It means any class that implements named instantly gets this useful display name behavior for free, no extra coding required, unless, of course, it wants to provide its own special version. Okay, but wait a second. What happens if a class implements multiple interfaces that have the same default method? Who wins that fight? Well, this table breaks it down. Rule 1, the class's own code always wins. If you write the method yourself, your version is the one that gets used. End of story. Rule 2, a more specific interface beats its parent. And finally, if two totally unrelated interfaces clash, Java basically throws its hands up and says, nope, not my problem. It gives you a compiler error and forces you, the programmer, to step in and resolve the conflict yourself. And all of this brings us to one of the most foundational principles of good software design: code to an interface, not an implementation. What does that really mean? It means by depending on the contract, the interface, instead of a specific concrete class, you make your code incredibly decoupled. You build systems where parts can be swapped out, testing becomes way simpler, and your entire application is just more flexible and more resilient. Interfaces aren't just a feature of Java. They're a philosophy for building software that's meant to last.